Hi, welcome to the Affinitive Design podcast by DEIV Architecture. I'm David Clayton, architect and president of DEIV Architecture, and this is Gary Acton. He's our BIM manager. He specializes in technology and CAD software, making sure that we're up to the latest and greatest in technology. Welcome, Gary.
Thank you.
Okay. Well, so today we're going to be talking about something that probably most people don't even think about when they go into designing a home or any kind of commercial structure. Even most people, they think, what does the architect do but draw pictures? Actually, one of the things that we have to do is to deal with environmental design, dealing with how the building performs within nature. So today we thought we would talk a little bit about one of the requirements for house designs here in the United States, and that is the REScheck. REScheck is a little piece of software that was written by the Department of Energy. Yeah, that's right. The government wrote this software. So let me show you what this software looks like. It's beautiful, isn't it?
Wonderful.
So anything built by the government, yeah, you're sure that it's going to be fantastic. Well, here's why I wanted to bring it up. So REScheck is assumed by a lot of local authorities as being something that you have to do because it demonstrates compliance with the energy efficiency standards in the United States. Here in Utah, we use the 2009 International Energy Conservation Code, or the IECC, for residences. Most of our code cycles were actually on the 2015 cycle, but on the energy efficiency code, we're actually on the 2009. So what we're going to do is we're going to illustrate why REScheck is a total joke, but why we also still do it. So it's ridiculous in the fact that in general you can do it without something that I think is really important, a consideration of where the building is situated relative to its environment. About the only thing it does is it actually has you put in the city name. So in this case, we're doing a sample project, and you see this is Salt Lake City, Utah. Okay, but that's the limit of what it is. Mm-hmm. Now, Gary, you know Utah pretty well.
Pretty good, yeah.
Okay. Is there a problem with saying, for example, Salt Lake County when it comes to energy?
Well, there's a wide variety of elevations and so forth, which changes the weather conditions and the conditions that these homes are in. So, yeah.
Yeah. So, like, for example, does Salt Lake County include anything more than just the downtown area? Does it include maybe, I don't know?
Not really.
Does it include something more than just the valley?
No.
Yeah, it does.
It does?
Yeah, it does, actually.
Oh, you mean the county itself?
Yeah, so the county itself actually extends all the way up to Alta ski area, which is up at 11,000 feet at its summit. 4,000 feet in Salt Lake City, 11,000 feet at Alta. You've got Brighton ski area as well. There's Immigration Canyon, which is probably around 6,000 feet of altitude. And those are also in the mountains, but they're in the Salt Lake County. So just within this really narrowly defined geographic area, we have what we call microclimates. And when you actually check the weather report for anywhere in Utah, you'll notice that you can actually zero into the specific zip code and get a much more accurate forecast for your specific area, because even just here in Bountiful, our office is in Woods Cross, which is right next door to Bountiful, but even within Bountiful, you go from the downtown area of Bountiful, which is at about 4,200 feet, all the way up to about 5,400 feet up on what we call the Bountiful Bench, which is up on the mountain. So, obviously, snow. The amount of snow that you get changes quite a bit. Based on that, what kind of winds you get, what kind of solar exposure you might get, because in some cases up on the mountains, you're going to be in perpetual shade by a mountain or by trees, or you could be in the valley and you could be totally exposed out in the desert and be getting harsh rays. This is something that REScheck does not it doesn't even remotely cover that, right?
Right. No, not at all.
So, regardless, though, it is something that we have to do. It's a part of the process of designing a home and submitting it for approval to the city. So, basically, the way REScheck works is after you fill out the street address and all that, we tell it what kind of construction it is. So, right here, it's 1 and 2 family, detached, or multifamily. We can put in the conditioned area. In this case, what we've done is we've selected this sample building here, and so we're going to go to the floor plan and measure up what that square footage is. And that square footage is 1,300 square feet. So we'll put that into our conditioned floor area. Okay, so here's the next part. It asks orientation, front faces. Now, what's interesting about this is you do not actually have to submit this. Ideally, what this is doing is providing what? Do you know?
Well, it's the sun exposure and so forth.
Yeah, exactly. And how does that affect it in a hot desert climate?
Well, there's a lot more heat with the sun.
Yeah, so obviously
the face is going to gain more heat that way.
So yeah, here in Utah, south and west exposures are the most intensely hit by the sun. So obviously your south exposure, but your west exposure, because of how hot it gets during the summertime and how long in the evening we have that western sun, all the way from usually about 4 p.m. until about almost 10 p.m. You've got the sun just beating down on the west face of the building, and you've already got all the heat built up to sometimes triple digits throughout the day. And so by that evening, the ambient temperature is already really hot. And now you're adding these intense sun rays coming in from the west there in the evening and just ripping apart any chance of survival for that building if it's not designed properly. So that's why it allows us to do orientation front faces. And in this sample, we're just going to do a quick south exposure, saying that the front of the building is that. One of the things that we have to do is we also have to keep hitting save, because this is a web-enabled app. There is a PC version.
Right.
Obviously, I'm using a Mac because I'm better than you. No, just kidding. No.
Because we're diversified.
No, we actually use both PCs and Macs in our office, and it's really just personal preference. I like to rag on Gary because he uses a PC. So the next step is to talk about the envelope. So, Gary, what's the envelope of a building?
Envelope is the exterior, whether it's the walls or the roof, which also includes all the windows and doors, all the exterior.
Okay.
Keep the elements out.
Now, how does that relate to energy efficiency?
Well, with these are all the things that separates the indoors from the outdoors, and which keeps the heat in or out, depending on what you need during the year.
Yeah, exactly. And so I liken it to a refrigerator. The walls of the refrigerator are heavily insulated so that the amount of energy used by the compressor to generate the coolness inside the refrigerator is less, because it's not having to work as hard to maybe cool the entire room. Instead, it's only cooling the little box that is the refrigerator. And so that's essentially what we're trying to do. We're trying to design a building so that it acts sort of like a refrigerator. It has enough insulation so that the mechanical equipment that is powering the cooling systems or the heating systems, depending on the time of year, it doesn't have to work as hard,
Right.
thereby saving electricity
energy.
or natural gas in the case of heating.
Right.
So on the envelope, what we would do is we would fill this out. So we have to put in our ceilings or roofs. In this case, our building, it has 1,300 square feet. It's pretty simple. It's a rectangular shaped building, right? So we're just going to set this as a flat ceiling or scissor truss. And on this, we're going to say the gross area, 1,300, because it's pretty much the same as the floor area.
Mm-hmm.
Now, the cavity value here in Utah, where we typically do a minimum of R38. There are some places, like in Alta or Park City, where we might have to go up to maybe an R48 because of the higher altitude and the much colder temperatures during the winter. Because we're doing this one Salt Lake City, we're just going to count that as R38. So there's cavity R value and there's continuous R value. The difference is, do you know?
Not specifically, no.
Okay, so cavity R value, that has to do with the insulation that's in between the structural materials. So in the case of a wood-framed house, this is the attic, right? We're talking about the attic insulation. So you've got your wood trusses every 2 feet. So in between that is your cavity. The continuous R value, that would be if you were to separate from the structure, you have just a layer of foam insulation, and it's a much more efficient way of building, but it's also a lot more expensive. So typically in houses, you would find a cavity R value of R38 using the blown in, usually the cellulose blown in insulation, mainly because that's the cheapest insulation to put in, and it works just fine so long as it's installed properly.
Right.
Okay, and we don't have any skylights, right?
Nope.
Okay, so let's move back to the building. So we've got our, it's a very simple structure, right? And just a rectangle. So we've got, looks like 4 walls. So let's figure out what the size of these are. So it looks like the north and south walls are both 56 feet long by 19 feet tall. Kind of a ridiculous shape, but that's okay. So our first wall we're going to set as a wood frame wall, 16 inches on center. That's kind of the standard. The gross area was 56 times 19. So let's make that a little bit simpler and say 56 times 10.
That's fine. Yeah.
That's 560. So if we're going the 19 feet, that'd be what, 1,000? So let's just say about 1,000 square feet. Orientation, this one is the front side. Cavity value, so here in Utah we typically use 2x6 stud framing with R19 batt insulation in the cavity. The other thing that we typically do, we use a lot of stucco here in Utah, right?
Yes.
And is it real stucco?
No.
What is it?
It's a synthetic polymer that you put on. And
so EIFS, basically
EIFS.
exterior insulating finishing system. It's an interesting product. It's basically styrofoam with an acrylic layer that looks like stucco. It's not actually stucco, but it looks like stucco. But it's actually better than stucco because of the it's a little bit elastomeric, right? You know, that acrylic layer is actually flexible, so it bends and shifts. So that way you don't get as much cracking. You still have to put control joints in, but at least it's a lot better. So on a residence, you'll typically see that at 1 to 1.5 inches thick. And using the expanded polystyrene foam that they use, that's typically about an R5 per inch. So let's assume that we've got 1.5 inches of that, And so we're going to put that in at 7.5 for our R value continuous. It's a pretty good R value, actually.
Yeah.
Okay. So we've got that wall, and now we need to add the 4 more walls. So we had the wood frame,
We have the back one,
16.
which is going to be the same.
That's going to be the same one. This is the north.
Be the back side.
Yeah, so back side, north face. And it's cavity 19, 7.5 for the continuous. Okay. And then let's add 2 more walls. So we forgot to measure the east and west walls. So we've got 24 feet.
By 19.
Okay. And it doesn't look like it does the area on that command. So it was 24 though, right?
Yeah.
So 24, so 240, 480. So let's just say 480 for gross area. That's on the right side. We're doing 19, 7.5. Okay.
And then can we just duplicate that?
Yeah, we could actually, you're right. So that's apply. Oh, looks like I forgot to tell it which orientation it is.
Right.
Okay. So now we've got our walls, foundation. We need to add our floor. So in this case, this is a slab on grade, heated. Usually in Utah we build with basements, so we would actually normally define those walls and put in an insulation value on the walls. If it's an unfinished basement, we would actually have a floor that has to be insulated above the basement, and that would be an R30 bat. In this case, we're just doing it a slab on grade, which means we've got a running length 56, so that's 112 plus the 24 and 24, so that's 48. So that's 120, 160. Okay, so we've got 160 feet of perimeter for that slab on grade. And our continuous R value, we're going to put 2 inches of foam for an R value of 10. And that depth of insulation is going to go down 2 feet because it's going to be going basically from the grade, right, down to the footing, which the footings here in Utah tend to be about a 12 by 24 continuous footing, and they have to, the bottom of the footing needs to be at frost depth. In Salt Lake City, that's 36 inches, so we'd be at 2 feet for our depth of insulation then. Okay, so we've got our foundation covered, and so one final check before we can do this accurately. We need to do our windows and doors. Okay, so on the south face of the building, we've got this window, which is a 7.5 by 5 foot window. So, so that's let's just make it a 7 just to make it easy. 35 square feet of window there on the south face, and so that means we're gonna add a window. It helps if you name the walls. And I'm sure this is just a scintillating video. I'm sure everybody's gonna be just having a blast watching this one. You can just skip ahead to the next minute.
You can also just fast forward.
Yeah. Okay. And then the left side. Okay. So on that front wall, we're adding a window. In this case, we're just going to say vinyl frame double pane low E. So it's really important to get the glazing type and the framing type right, because the software actually calculates based on the different types. Unfortunately, they're not very accurate, but you can actually choose other and assume something different. But in our case, we're going to just call it out as a vinyl window just because that's easier. So this is 35 square feet of window, and the U factor. Okay, so what's U factor? Do you know how to explain that?
No, I don't.
Okay, so U factor actually is related to R value, and it's actually the inverse. So whatever the R value is, it's basically 1 over the R value. And so in the case of a window or a door, it's always calculated in U factor, which obviously, because it's a ratio, you want it to be as low as possible to get the maximum R value or the maximum energy efficiency.
Right.
So in this case, here's the interesting thing about REScheck, or its commercial architecture variant, ComCheck, where they basically ignore the fact that in 2009, the stimulus bill passed by Congress and signed by President Obama, that law, a lot of people don't realize that, but it actually regulated windows in the United States to meet or exceed the standards of a 0.3 U factor and a 0.3 solar heat gain coefficient. And yet, the REScheck and ComCheck still allow and even default to like a 0.7 U factor. It's ridiculous. So I always put in a 0.3 because if you get a good energy efficient window, honestly, it's going to be better than 0.3 anyways. So that way you can have that. If you don't have, if you want to be a little bit more accurate, you can actually go to a window manufacturer's website and pull up that information. Great.
Definitely, yes.
And so in this case, we've got that window. Looks like our west exposure does not have any windows. Our east exposure has a 5x5. And looks like our north face has 2 more 5x5 windows. So we're going to add another window. This one to the, this is going to be the right wall. Vinyl frame, double pane low E, 25 square feet, a U factor of 0.3, and we'll apply. And then another window, low E, on the rear wall.
And you can double up
25.3. That's true. We could actually, and that points to another thing about the REScheck, right? That it's not actually calculating based on the location of the window or where it is on the wall, whether or not it's in shade. Right. It's really just factoring, hey, there's this much glass versus the wall assembly, which is the R19 plus the 7.5 continuous, right?
Exactly, yeah.
Okay, that's a good point. So in this case, we can save a little bit of time by cheating and putting those 2 5x5 windows together for a total of 50 square feet of glazing. And then if we looked back at the south exposure of the building, we had one door for this whole entire building. And so let's add that in on the door.
Front wall.
That was a solid door on the front wall. And gross area, it was a 3 foot by 7 foot door, so that's 21 square feet. The U factor, again, we're going to put in a 0.3. I'm going to hit apply, hit save, and here's where it gets fun. We hit compliance check. Okay, so if you look up here in the top left corner, it looks like we pass. We beat the code requirement by 14.6%. So happy day. At this point, we could fill out the compliance check that goes through a bunch of regulatory stuff that the contractor has to comply with. So in this case, we actually are going to be, we haven't been in the past, but we're actually going to be starting to put this on our plans regularly, on a specific sheet, so that the contractor can't miss it. They will see this and have to comply, largely because the building inspector is going to force them to comply anyways. So basically what we're trying to do is we're trying to help our contractors see this before it gets to the point where the inspector's coming out and they've already done it, and now they look like a genius because they've already done what the inspector's going to tell them to do.
Right.
And then we're going to click on report, and we're going to include everything. And then what we do is that produces a little report, downloads as a PDF, then we open it up, go through it, just double check everything, make sure it's good, sign it, and then we place it on the plans and submit it to the city with our building plans.
Right.
So, does it actually help?
To a point, yeah.
Yeah, so how does it help?
Well, it does give a basis of design of how, we want the energy, how we want the walls and ceiling, roof to perform for greater energy efficiency. Save money for the owner and
yeah. And again, so the benefit to this is that we are forcing the building industry, through governmental regulation, it's forcing the building industry to get more energy efficient in the construction of buildings, so that we are getting much closer to what many people would like to see, which would be a net zero future where we're not using any additional energy than what we're able to produce. And that implies having solar panels or wind generators or other renewable resources. But the idea being is that we're not using any more energy than we have to in order to heat and cool the home.
right.
On the flip side, the problems that we've talked about.
Right.
We've got, this doesn't account for where it is altitude-wise on the mountain, or whether it's got a prevailing wind that's constantly striking it from one angle, or if we've got the sun exposure, depending on where that is, how it's striking. I mean, for all we know, there could be like a whole thicket of trees in front of the building that's keeping it in perpetual shade. And now all of a sudden your energy efficiency changes dramatically based on the presence of those trees.
Right.
Or up in the canyons, up at Alta or Park City, and in many of these locations where a lot of our clients are building, it ends up being, you might have like a big rock cliff just completely blocking the building's access to the sun, and great, you're getting more energy efficiency that way, but you're also staying a lot cooler even in the winter.
Right.
Because you're not getting the benefit of that sun striking it during the winter to help warm up the building. And so in a future episode, we're going to talk a little bit about passive solar design and also prevailing winds, how you can actually design a site so that your building will actually perform better. And we're also going to talk about how you can design a building so that it will perform better by not even worrying about all these numbers, but we can actually just do it by understanding the science around the building and help it to function better in nature.
Right. Definitely.
So thank you again for joining us. I know this is probably not the most exciting topic, but honestly, it is a very important topic, because that's something that we have to do every day, is make sure that the buildings that we design are not only meeting energy code, but they're just creating good quality spaces for our clients. So thanks again for joining us. And again, I'm David Clayton.
I'm Gary Acton.
And you have a wonderful day.